Well, hello everybody. This is Mr. Goodman, and we're here at the top of Trans Old Bridge with Hannah and Danielle, and we're going to ask them to do an experiment on the hill. Hey girls, how steep do you think this hill is? Give me an angle. The road has got an incline here, and they're going to try to figure out how steep this is. So, what's your estimate, girls?
Like 40 degrees. 30 degrees.
So we have 30 and 40 degrees. Let's take a measurement with the inclined plane and we'll see what the angle really is. We've got the ramp set up on a basket so that we're trying to make it level. She's going to give it a tap. Okay, stop it. Yes, good. Tap it the other way. Okay, it doesn't really want to roll downhill either way. So I think we're pretty level. The ramp has a tape measure already built in. And now we have to measure the height, bottom to bottom. So now we have a length and a height.
It's 11.1 divided by 214.5, and then the inverse tan of that number.
And what do you get?
2.96 degrees.
Wait a minute, you're telling me this is only 2.96 degrees?
I guess.
And you were estimating 30? Well, I got news for everybody. This is psychology. When you are dealing with gravity, we overestimate the steepness of the slope. You can go and interview people who ski down ski slopes and ask them what the hill was that he just came down. They will overestimate the angle of the incline greatly. Gravity is a scary force. Now the fun begins. We're going to let this cart roll down the hill. And then we're going to calculate the acceleration due to gravity. Danielle's going to release the cart from 20 centimeters, and we're going to stop it right here at 220. Okay, go ahead.
Release it?
Yep. One, two, three, go. So we got an average time of 2.74 seconds to go down. That was 3 trials. Using the formula distance equals 1/2 AT squared, and the distance being 2 meters, we solved for the acceleration and got 0.532 meters per second squared. Well, that's the acceleration parallel. That's the G parallel. If we divide by sine theta, which we got above as the 2.96 degrees, we get 10.32 meters per second squared. We need units. Now, don't we feel better? 10.32 meters per second squared. The correct answer? 9.8 meters per second squared. That's the theoretical. Hey, we're on the money. Here I go. So we just measured the car going 10 meters from rest. And what did we calculate? So we went 10 meters in a time of 7.05 seconds, and we throw that into the distance equals 1/2 AT squared formula, and we get an acceleration of 4.02 meters per second squared. Well, that's at the same angle, the 2.96 degrees. That gives us an acceleration due to gravity of 7.79 meters per second squared. How come that's so much lower? Check out another wheel. These things spin really well. How do you think these things spin? I mean, really? It's rubber. It's going to compress. There's going to be a lot more friction with the car than with our cart. So how does anybody know if you really like physics? You come outside on a beautiful fall day and you measure the acceleration due to gravity outside your house. Thank you very much, girls.